Hi everybody, you're tuned into My Dad Says Audio. If you've been here before, welcome back. If you're new here, welcome. Today we'll be taking a look at my dad's custom CD player. Dad, what can you tell us about the player today?
Well, we're going to try and do a two-part video. Today we will be covering the transport side of things. What I'm trying to do here is a bit unique. The other thing I should do is a disclaimer straight away is mains voltages are involved with this. This is not a how to do video, but just a disseminating information is how I would describe it. So if you don't know what you're doing with mains voltages, please don't do any of this stuff, is how I would describe it. I'm just trying to think here. This part is going to be the transport side of things. I think this is a bit of a unique transport per se. I've never seen anyone else do this before. It is based on, because it might seem a little bit wild, how do you know it's going to work? I have done this with a different CD player, very similar, Philips-based machine, but which was a Rotel RCD 820, which you can go and have a look at. With this one, it's based on a Rotel RCD 955AX. Okay, for those that are a bit observant and like have an interest in this sort of area. This has the TDA1541A DAC chip in it, just as an interest, but we'll be dealing with that side of things, the D to A and analog stage, in the second video. In this one, just want to focus on the transport side of it. You might have noticed we have, I'll just show you here, that's the standard motor that comes fitted in the vast majority of machines. You can see there, I've taken that out at one stage. So that's the standard motor. I'll be using this motor. Now, I don't know how many of our viewers will recognize it, but this is out of a Pioneer Laserdisc motor, out of a Pioneer Laserdisc player. So it's designed, this motor is designed to spin a disc, which is 12 inches, much the same as a record, but it weighs about half a kilo. So it should quite easily be able to spin your little silver discs, yeah, with far more control than with a little motor like this. One of the things a lot of people don't realize is the objective of a laser reader or the motor itself is constant de-acceleration. For other words, it starts reading at the center of the disc and gradually the laser will read the pits and lands from the center outwards at a constant velocity past the laser head. In that respect, it's a lot more similar to, say, a tape recorder than a turntable, for instance. A lot of people look and go, oh, it spins discs, so it must have some similarity to turntable. Not really. What it is a constant de-acceleration with respect to the data on the disc as it's read outwards. So it's constantly de-accelerating. Now, one of the features of this motor is it has a slight drag to it. So whereas this just spins quite freely, which is probably not really desirable. You know, you're relying on the friction of the clamping mechanism to provide the braking, whereas with this, that's provided by the motor itself. You can see, if you look here very carefully, see that hole there? If I turn that, you might be able to see. Can you see in that hole?
Yeah, keep turning.
Can you see in there?
Keep turning, yeah.
I'll have a look. And yeah, you can just see it there. See,
yeah.
I'm turning it. So I think it's called a stator, or the part in there that actually rotates, compared to your average CD. It's a defective disc too, don't worry about that. Maintains huge control. Now, a lot of people are probably going to go in the comments section and go, it makes no difference because it's buffered, and as long as you're picking up the pits and the lands, or the one, the ones and the zeros, etc., makes no difference. All I can say is I've helped produce a machine that's used this motor, and all I can say is it's quite stunning, the difference it makes. It surprised me and quite a few other quite experienced audio nuts, is all I can say. It will be very hard. You probably notice from our channel, I don't often get that interested in digital audio so much, but this does definitely spark my interest. Oh, the other thing is, I've got to put this in. That's not a motor. This is a motor. I had to put that one in. Crocodile Dundee. That's not a motor. This is a motor. Anyway, I'll try and explain. You can see here my metalworking skills are not the greatest, but this will mount. This mounts, I'll just get it correct, like so. I'm going to take those screws out like so, and then I've shimmed this so that you can then put that over that. Now, I'm not going to pull it apart to totally show you, but that gives you somewhat of an idea of how it actually is going to go together. And the only thing is, with what I will do, I'll do a little bit of a mock-up, and you can actually see it spinning. Oh, I begged one of my good friends to, you can see there's the original CD part that holds onto the CD. You can see here, like so. Had a friend who had a lathe to drill that out and put an insert in the correct diameter for that, because quite obviously it wasn't going to work from that onto that. So there's that part, and also a nice little brass puck. If you look there, nice little solid brass puck. Now we put the CD on. This is just a mock-up, give you some idea. Now I have to actually tape the motor down. We did try this before because of, I've got a little carbon fibre mat for that. I've got to tape it down, and I'll show you it running. Say, it's got that much torque, it will jump. When you actually get these things running, as I have with this other machine that I helped get going, when it starts, sometimes there's a little screeching noise because the motor starts turning before the disc and the puck. Anyway, we'll try and show you here. Let's see. This is a 9-volt battery. This will give you some idea of what it'll do. Okay. There you go. That's probably as fast as it'll ever go. But if you look, see that can you see the braking effect?
Yeah.
Yeah, so that's what's the desirable part. A lot of people think, oh, low friction and all this. No, I think this has magnetic braking as part of the aspect of the motor itself. So there's that part of it. And the other thing I thought I'd show you is there's certain parts of the circuit which need to be powered differently. Here you'll see, might look a bit messy, but here you'll see there's I've built a power supply which will supply, I'll just get a diagram out. I'll just try and get a diagram out. If you have a look here, there's a couple of parts. This is the motor drive circuit. Or maybe I'll show you this first. This is a block diagram, I think they call it. Yep. If you look here, there's the motor. And then you come down here. That's a block. I think that's a dual op amp plus 2 transistors for the actual motor drive itself. And then it goes off here to this chip up here. So what we need to do, or what I'm going to do, is a completely separate supply for that, which is 5 volts, runs off 5 volts. This, which runs off plus or minus 10 volts of 2 points. I'll try and show you this part in more detail. If you look down here, this is not usually where most people go to improve their CD player. But if you have a look here, it's a dual op amp. That's a dual op amp. And here there's 2 transistors. Now, the transistors, a couple of things. The transistors, which are normal TO92 transistors, which I'll try and give you an example of here. See there? Those. They actually drive the motor. Now, they have no problem driving a little motor like that. Quite obviously, a motor like that is a different kettle of fish. So what we do, rather than those little TO92s, I'm going to use these BD, I think it's BD 139 and 140. I can get them out. They're complementary pair rather than the tiny little TO92s. So we substitute those for those. Plus I think these are the emitter resistors. I'll up the wattage on those. The other thing is I'll be running, as you can see here, a fully regulated supply, which, because power supplies and a lot of this stuff is, relatively speaking, a bit marginal, to try and cut it to the bone. You do something like this, which is significantly more substantial, it should have no problem at all driving this, has been my experience. But you can't, that alone, when we built this other machine, when we first fired it up, one of those transistors especially ran blazingly hot. It's a bit amazing it didn't just fall over straight away. But yeah, if I can get it going, it's quite a bit of work. If I can get it going, it's quite an amazing platform to build off to get something that's pretty exceptional, where you start looking at the mastering, etc., of the actual CDs you're listening to. I'm more of a vinyl fan, but there's something that I recognise with the sound of this, and I know people, they're going to come at me in the comments section. Oh, you're crazy, this is how it works, it can't possibly make a difference. All I can say is if you actually try it and have a listen, I think you'd be surprised. I have helped build one of these machines. I did all the electrical work. I didn't do the mechanical work. I didn't do all this part. I did all this sort of part. So anyway, I thought we'd show you this, and I'll be interested to see what happens as far as people's comments go. All I'll ask is you try and keep it a little bit respectful as far as the comments go, but I'll be interested to see what people think.
All right, that's it till part 2?
Yeah, till part 2. Part 2, we'll try and cover other parts of it. The TDA1541, 541A DAC. I've got a few interesting things, I think, to say about that, plus, of course, the actual output stage itself.
Yep.
The objective here, of course, is this will no longer be, that's the other thing, it will no longer have, I don't have the sled anymore. There is one thing that I've got to change if you're going to try and do this sort of stuff, is there's a limit switch just there, little limit switch. When the tray goes in, that gets depressed from memory. Now, that doesn't just tell the draw motor when to stop and start. It also tells the machine that there's a new disc on. So, for instance, if I was with this, I've got a switch somewhere. Where is it? Yeah, got a switch. I'm going to fit a little switch, the limit switch, so I can flick it on and off. It's quite possible I could use a momentary as well, but we'll just use that for the moment. It tells the machine that there's a new disc being loaded. If you don't do that, and let's say you've got a disc that was 10 tracks long and you put a new disc on and it's 15 tracks long, it won't, from memory, it won't read the last 5 tracks.
Yeah.
It'll play the other ones, but it just goes, no, there's only X amount of tracks on it.
Yeah.
The other thing is, if you look at the laser, the actual lead out on the laser assembly, I've got it shorted so we don't get any static problems. If you have a look here, it normally plugs in there. What I'm going to have to do, because this whole assembly is significantly larger than what was originally in there, is I'm going to have to carefully lift this and raise it by about 2 inches. You might think, it won't work, at these sort of frequencies, etc. No, I've actually seen the machine that I helped do before actually had this about 1 foot long, which I think was a mistake, but it's interesting, it still functioned. So me raising that by about 2 inches should make no real difference at all.
Yeah.
Okay, that I think covers the transport side of it. Next one, we'll try and do the D to A and output stage.
All right, everybody, hope you enjoyed the video. If this is your kind of content, please consider liking, commenting, subscribing, and sharing. All right, until next time, have a good one, guys. Bye.